Welcome to the sixth lecture of the course ARM and Embedded System. So, in the last lecture, we have seen that is four elements. Again, this is the another part, that is other system components which is required for an embedded systems. Either they may be inbuilt or we can provide externally, which is very essential for an embedded systems. So this is the last topic, that is other system components. So what are these other system components? That is reset circuit, brownout protection circuit, oscillator unit, RTC, that is real-time clock, and watchdog timer. So let us see one by one. So what is the reset circuit? So you can see here the reset circuit is essential to ensure that the device is not operating at a voltage level where the device is not guaranteed to operate during system power on. So that is the reset signals. So that means the reset signal brings the internal registers and the different hardware systems of the processor or the controllers to a known state and starts the firmware execution from the reset vector, that is 000. So the reset vector can be relocated to an address for processor or controller supporting bootloader. So the reset signal, so you can see there are two types. Either it may be the reset signal is built like this. So either it may be in this form, either it may be this form. So the capacitor is connected at the VCC or the capacitor connected at the ground level. So the reset signal can be either active high or active low. So why this, what it will do, the reset, that is reset circuit is essential to ensure that the device is not operating at voltage level. So whenever we press reset signal, so we have seen on the hardware, that is controller or the processor, they are provided with the reset button. So actually this reset button, so whenever we get stuck into the process, so automatically when we press that reset, so again the vector will become 00. So it will start from the 000H. So that is the reset circuit. So these are the essential components required for an embedded systems. So next we'll see brownout protection circuit. So we can see here this is the brownout protection circuit. So what this brownout protection circuit do? So that is it will prevent the controller or the processor from unexpected program execution behavior when supply voltage to the processor or controller falls below the threshold voltage. That means the processor behavior may not be predictable if the supply voltage falls below the recommended operating voltage. So if it falls, it may lead to the situations like the data corruption. So a brownout protection circuit holds the processor or the controller in reset state when the operating voltage falls below the threshold until it rises above the threshold voltage. So certain processor or the controller support, they will have a built-in brownout protection circuit which monitors the supply voltage internally. If it is not built in, so we have to connect it externally to the processor or the controller. So this is the brownout protection circuit. And next is oscillator unit. So we can see here, so what is oscillator? So a processor or a controller is a digital device made up of digital combinational and sequential circuits. Everybody know that. The instruction execution of a processor or controller occurs in synchronism with the clock. So in clock signal. So what this oscillator unit, how the clocks are generated. So every embedded system or the processor or a controller, they require oscillator unit. So oscillator unit, it will generate, why it is required? So it is required to generate a clock pulses. So all the instructions are executed in the processor or controller in synchronization with the clock signal. So how clocks are generated? So they are generated using this oscillator unit. So that is thing. The oscillator unit of embedded system is responsible for generating the precise clock for the processor. Certain processor controllers integrate a built-in oscillator unit or simply require an external ceramic resonator or the quartz crystal for producing the necessary clock signals. So they may have again, so these are inbuilt or it may be connected externally. So quartz crystal oscillators are examples for generation of clocks, that is pulse generating devices. So we have seen, so this oscillator unit, if it is externally, that is connected. So we can see here how this clock, this is a crystal, so capacitor. So this is, if it it is inbuilt, so this is the crystal. So if it is not inbuilt, so we have to connect externally to the processor or the controller. So next we see the real-time clock. So everybody, so we have heard of real-time clock. So what this RTC, the system component. So this system component, it keeps the track of time. That is, RTC holds information like current time, format, that is date, month, year, day of the week, etc., and supplies timing reference to the system. So the RTC contains, RTC contains an chip, microchip for holding the time and the data, that is date related information, and backup battery cell for functioning in the absence of the power in a single IC package. So RTC is available in a chip format, so which contains the battery backup as well as the chip which contains this, which holds the time and the date for the related information. So this RTC chip is interfaced to the processor or controller of the embedded system. So RTC is intended to function even in the absence of power because it is having a battery. So RTCs are available in the form of ICs from different semiconductor manufacturers like Maxim, Telas, or ST, Microelectronics, etc. So last we'll see watchdog timer, that is WDT. So a timer unit for monitoring firmware execution. So firmware is nothing but software execution. So as the embedded system, it is a combination of both software and firmware. So to monitor the firmware execution, so it should have a watchdog timer. So we can see here external watchdog timer unit interfacing with the processor or the controller. So depending on the internal implementation, a watchdog timer increments or decrements a free running counter with each pulse and generates a reset signal to the reset processor if the count reaches to 0 for a down counting watchdog, or the highest count value for an up counting watchdog. So what actually free running counter? So if something will happen in the processor, in the firmware, so it will start, so you can see this, so it will identify, so whenever identify again, so it will count either increments or decrement according to the each clock pulse and generates a reset signal. So once it will it will take the system clock here, and the same system clock is used by the processor or the controller. So if any problem will exist in the firmware, so watchdog reset, so it will send, the processor will send to the watchdog that is something has happened in the software. So then it will count again free running count, either an increment or the decrement, and again it will go to the reset pin, and again it is reset to the starting of the process. So that is the watchdog timer. So in firmware execution, if the firmware execution completes before the expiration of the watchdog timer, it can be stopped from the action. So this is the regarding watchdog timer. So with this, it completes the third module, that is ARM, that is of the course ARM embedded system. So that is module 3, embedded system components. So just to summarize, so what all we have studied in this core, that is, first we have seen what is embedded system, what are the types of embedded system, what are the purpose of an embedded system, what are the application areas of embedded systems, and we have seen what are the core elements of an embedded systems. So in detail we have seen all the elements, and with that next we have seen what are the other important components required to build an embedded systems. So thank you. So if you like this videos, all the lecture videos, please like, share and subscribe. Thank you.